Okay, so this one is primarily about cranial nerves, which are pretty cool to get to learn about. So there are 12 pairs of cranial nerves that are in your brain, and they control a lot of the things in your face. Um, and they are named from rostral to caudal. The little pneumatic is on occasion. Our trusty truck acts funny. Very good vehicle anyhow. Um, or once one takes the anatomy final, very good vacations are heavenly. So that's a little like mnemonic on the cranial nerves. So here they are, and they're numbered here, so you can see the Roman numerals. So you have the olfactory nerve up here in the front, the optic nerve right here, the oculomotor nerve right here that controls eye movement. So hopefully it's obvious what these control. So optic nerve is eyesight, olfactory is smell, ocular is eye movement. Then you have the trochlear nerve right here, trigeminal here, abducens back here, and then facial nerve is right here, vestibular cochlear nerve here, glossopharyngeal nerve. Vagus nerve is 10, my camera's in the way, but accessory nerve and hypoglossal nerve. So that's where they're located in the brain. And this is what they do. So some of them have multiple functions, but this is a really handy table where you can write down some of these different functions. Oops, I skipped one, shoot. Okay, so here's your first one, the olfactory nerve is right here. It's a sensory neuron, and it helps with sense of smell. So purely sensory, sense of smell, pretty cool. So that's where it's located. In that tissue. It's not just like the nerve fibers are hanging down. It's in that tissue. Okay, then optic nerve come out of your retinas, which is the back of your eye. And they pass through the optic canals. They converge at this spot called the optic chiasma. And then they synapse at the thalamus. So right here, this is the chiasma where they cross. And then, so yeah, this is called your optic tract right here. And they come out from the retina. So right here's the back of your eye where you, like an image is made, right? And it's upside down, and then that information goes to your brain. And then it's going to get sent back to your occipital lobe back here. Oculomotor nerves help with eye motion, like you're moving your eyes, raising your eyelid, directing the eyeball, constricting the iris, and controlling lens shape. So right here's where they come from, and they're attached to these eye muscles too, and then they go back into your brain stem. So they have motor function, and they have a little bit of sensory function too. So trochlear nerves also direct your eyeball, like they're motor nerves to tell your eyeball how to move. So right here, hooked up to that muscle, and then it goes back into your brain stem. And I don't think there's any sensory function. I think they're just motor. Oh, also proprioceptors, like telling your brain where your eye is and what it's doing. Okay, trigeminal nerves, these are the largest cranial nerves. They go to your face, like from your pons to your face. There's 3 divisions, the ophthalmic, maxillary, and mandibular. And they are sensory. They have a little bit of motor, but they're like 1 and 2 are sensory, and then mandibular is motor for chewing. Okay, so here's the 3 divisions of the trigeminal nerve. Let's see if there's a picture. Oh, and it said on the last slide, this is what dentists might anesthetize when they're working on you. So the first part is up here in the front. That's V1, and then V2 is here, and V3 is down here. So these top 2 are sensory, and then the bottom one has a motor component to help with chewing. So usually provoked by some sensory stimulus such as brushing teeth or even a passing breeze hitting the face. So that's that feeling you get. Okay, abducens nerves. They're mostly motor, and like in your eye area, and they innervate your rectus muscle. So right, where are we? Are we on the right slide? I think we had this slide already. And I think we're past this, so I don't know if this is right. Anyway, let me see. Yeah, that was the wrong slide, I think. So hopefully you can find a picture of that one. I don't know what I did. So facial nerves are number 7. This helps with taste. So they have sensory function with taste, but they also have motor function and help with facial expressions. Also with salivary glands. So this nerve is pretty important. And if you've ever heard of people getting palsies, which are where one of the nerves quits working, it could be with one of these. You can get a palsy in any of these nerves, and this one would be a really bad one to get a palsy in. Okay, so facial nerves, I think the pictures are better, but this is a useful graphic that kind of shows there's 5 major branches: temporal, zygomatic, buccal, mandibular, and cervical. So here they are: lacrimal gland up here, and then they also have a function in taste, and in your tongue, and your sublingual gland, and your salivary glands, and then also in facial expression. So here's a little simple way to remember the branches. So temporal, zygomatic, buccal, mandibular, and then cervical is your neck down here. So it's a pretty busy nerve. That one's really important, number 7. Okay, vestibular cochlear nerve. This deals with your hearing receptors and equilibrium. So bringing in information from your ears. Used to be called auditory nerve. Now it's called vestibular cochlear, which is more accurate because vestibulo is the balance part, the equilibrium. And so that's more accurate because it's not just auditory. There is a little bit of motor function, but mostly sensory. So here's where they're located, coming off the pons. And then this right here is your cochlea. So that's the cochlear part. That's what does the hearing. And then this right here is your vestibule. This is your, these are your semicircular canals that control balance. Okay, then number 9 is the glossopharyngeal nerve. This goes to your throat, regulates the motor function of your tongue and pharynx. They work together to swallow. Also, salivary glands, sensory functions. So there's both motor and sensory with this nerve, these nerves. So right here is where it's located, controls your tongue, swallowing, pharynx, all of that working together along with saliva. Your vagus nerve is, it's the only one that extends beyond the head and neck. It helps regulate the heart, lungs, and abdominal viscera, so that's motor function. And then also sensory function from the tongue and pharynx, and then some stuff in your thoracic and abdominal viscera or your guts and baroreceptors and chemoreceptors. So coming here off your medulla oblongata to your pharynx, and then your, what are we looking at here? Here's your carotid, right here's your pharynx. And then your heart, your lungs, and then some other visceral organs. Accessory nerves, that's number 11. And these form little rootlets that go to your cervical vertebrae 1 through 5 of your spinal cord. And they go down to your sternocleidomastoid muscle and your trapezius. So they're not in the brainstem like the other ones, this nerve number 11. And then it goes to these muscles right here. Okay. Number 12 is hypoglossal nerves, and they innervate your tongue and help you with swallowing and speech. Okay, so right here into this area. Okay. Okay, so there they are again. Now you kind of know what they do. They're pretty cool. I think this is the same graphic that we saw before. They are, let's see, the olfactory and optic nerves are made of neuron cell bodies. And then the other nerves that have sensory functions, their neuron cell bodies are in the cranial sensory ganglia. So they have like slightly different structures depending on which cranial nerve they are. Some are mixed and they have both somatic and autonomic fibers, because you saw some of them have multiple functions, and some of the functions are somatic and some are autonomic for sure. So to remember primary functions of cranial nerves is sensory, motor, or both. This is like in order, the 12 nerves. Some say marry money, but my brother believes it's bad business to marry money. So that tells you, like, are they somatic or both, or motor? Sorry, are they sensory, motor, or both? And that's it.